Hello, everyone. Good to have you with us again. We've been learning an awful lot of words in math lately, so we're going to take a little bit of time to review them. We're going to go back into our notebook from what we recorded yesterday. So these are some of the multiplication words we've been working with. Remember, when we talk about the words factors, those are the two numbers that are multiplied together to create our product. A factor pair is a set of numbers used. So for example, when we're talking about 3 times 6, 3 times 6 are a pair of factors. Yesterday we learned two new words, prime and composite. Don't be alarmed if you don't remember what they are yet. It takes practice with these. Remember, a prime number is a number that has one array. It's one rectangle when it's multiplied. And a composite number is a number or a product that has more than one rectangle. These are some of the posters we were using yesterday. For example, if I put the number 6 on, you can see that we have two rectangles, so we know it is composite. When we look at this number, 23, you can see we have only one rectangle, one array. That shows us it is prime. Remember, an array is a rectangle that is filled with tiles or squares. So this would be the array. It's also like the area of something. And sometimes our arrays are square. When they're square, it means that we have the same number of rows and the same number of columns. In this case, 5 times 5. So it's called square because its array makes a square. Today let's see. There are a few more words I want to remind you of. I talk about dimensions. Remember, dimensions are the outside of a rectangle. Can you see that? Good. And we think about just two of the sides, the length and the width. So if we would have 3 as our length and 8 as our width, our dimensions would be 3 by 8. If we filled this with 3 rows of 8 little squares and we counted up all of the squares, this would make its array. This would be the area, and the area would be 24 little squares. Again, if we're talking about the factor pair would be 3 and 8, which are also the factors. And when we multiply them together, it gives us the product. Since if we're thinking about prime numbers versus composite numbers, and I look at these, I know that 24 is an even number, and we discovered yesterday that even numbers usually have more than one array, so it would be a composite number. A prime number only has one array. Its factor pair would be the number 1 and the number, like 2, 3, 5, 7, 11, 13. So think about those. Those are numbers that cannot be divided in half without using a different factor. 2 is a special case, which we will get into on another day. So as a class, we are working on page 16 first. The class is already open to this page, so at home, if you have to pause the video to get this out, please do that. Otherwise, we're going to get started. I'm going to use these smaller versions of the posters that we made in class. And we're going to do these together. We're not going to do all of them, but we need to practice what these things mean. So it asks us to get our poster for number 12. Here is the poster for number 12. David, can you shut off the front light? Thanks. So when we look at these, we can see how many rectangles. Raise your hand, someone. Tell me how many rectangles we have. Jacob. Adrian. 3. 1, 2, 3. So fill that in. Yes. Now, this is what people might say, what do you mean dimensions of rectangles? I don't know. So when it says the dimensions of the rectangles, what are some of the dimensions? You might have to write kind of small. So I am going to draw a line like this to give me enough room. Do you see why we're not going to fill in all of this? So if I look at the dimensions, does anybody have an idea what the dimensions might be? Name a set of dimensions, Phoenix. 3 and 4. 3 times 4. Okay. Is there another set of dimensions we can write? Luke.
6 times 2.
Okay, 6 times 2. Is there another set of dimensions we can write? Adrian. 12 times 1. And now it says factors of the numbers. That means we have to write all of the factors for the numbers. So this is a helpful hint for many of you. You can do this 2 ways. Remember a while back, a few lessons ago, we made factor charts. And we thought about 1 times 12. The next number after 1 is 2, and we know that 2 times 6 works. The next number after 2 is 3, and we know 3 times 4 works. But now look, the 3 leads right into the 4, so we don't even have to find anymore. We found them all. Because if I would go to 4, well, I would have 4 times 3, and that just makes more work than we really want. And how many of you really want more work? A few people even raise their hand. They want more work. So you can list your factors in a number of ways. Okay, people out there, I'm going to draw a line between this because there's 2 different ways you can list your factors. Some people would think of it like this: 1, 2, 3, I'll put commas between them, 4, 6, and 12. Other people would write them in the factor pairs: 1 and 12, 2 and 6, 3 and 4. Do you see any multiplication signs when I'm listing my factors? Okay, I have people shaking their head no. When you list factors, you don't need to put the multiplication signs in. And don't worry, we're going to come back to this page one other day, and we're going to do this last one. We're going to do 2 of these just to practice. But we need to come back and practice this one more time so that we remember what this really is about. Looking at this, what do you think, people? Prime or composite? We have a few people saying composite. Why? Raise your hand so I can. Okay, Phoenix has his hand in the air.
Because there's many multiplication facts.
Okay, so he says there's a bunch of multiplication facts. And there's a bunch of what up there? There's more than one what? Yes, sir.
More than one answer. More than one answer.
Okay, there's more than one answer, more than one way to get the answer. Well, that's a good way to think about it. I didn't really think of it that way. Adrian just said there's more than one way to get the answer. That would make it composite. Maybe his explanation makes more sense to you. A lot of students in the past have said you can make more than one array. And that's how they would answer that they know it's composite. Well, Adrian's thought is, well, you can make the answer in more than one way. And remember, 12 times 1 and 1 times 12 are the same thing. 2 times 6 and 6 times 2 is the same thing. 3 times 4 and 4 times 3 is the same thing because we are using the commutative property. Ooh, hands went up because they thought I was going to ask about that. Okay. Now we have decided this is composite. How many of you would rather just write a C instead of composite number? Okay, so you can just put a C. Okay, we're going to do, let's take a big number.
15. 30.
How about 31?
Oh, I was so close.
Looking at 31, we're going to write 31 here. How many rectangles do we have? Raise your hand. Luke, one rectangle. What are the dimensions?
1 times 30.
1 times 31, that's it. So what are the factors?
31.
1 and 31. Notice I did not write a multiplication sign when I wrote the factors. Again, like I said, we're going to practice this again. It's hard to learn this just in one day. What do you think this is? A prime number or a composite number?
Prime.
Why do you think it's prime, Adrian?
Because there's only one answer.
There's only one way to write it. And remember, 31 times 1 is the same as 1 times 31. Okay, so I'm not going to make you do the next one on your paper. We're just going to discuss the next one, and I'm going to write some stuff down here. Let's do the number 27. Oh, I just accidentally took a picture of something. Again. Ah! Sorry, people. I don't know what's happening. Okay, people out there, I gotta pause this to see what's going on. Oh, okay, I think it stopped. Oh my goodness, technology. Okay, we gotta get ourselves calmed down. I hope that you at home had a good laugh too. Okay, moving on. Down here, I'm gonna work this through. Okay, remember, it says on top the number. Our number is 27. It says number of rectangles. How many rectangles do we have? Show me with fingers. Some of you aren't paying attention. I need you to show me with fingers. There we go. There are 2 rectangles. Dimensions of the rectangles. Who can tell me the dimensions of these rectangles? I'm looking for a new hand. I always have the same few hands up. Nobody's brave? Oh, they're all shaking their head. No, they're all afraid because they're being recorded. Okay, Luke, tell me about it.
3, 9, 1, and 27.
Okay, so remember, dimensions are the factors. So we have factor pairs. So we have 3 times 9, 1 times 27. And then it says factors and numbers. This is when you don't use the multiplication sign. So we just listed them from over here. Now, is this prime or composite? Who's going to be brave? Anybody brave? I'm looking. I have my same few hands in the air. Trevor, what you think?
37.
Okay, is it a prime number or a composite number? You have a 50-50 chance. Brooklyn? It is composite. So we put a C. Okay. Those of you out there, you now need 36 of something that are the same, like pennies, or if you have little tiles, great. The class is going to get out 36 tiles, so I am going to pause this while we get ready. Okay, everyone, we are back. It took us a while to get our 36 tiles out because that's a lot of tiles. So I'm going to show you what mine looks like. Well, actually, you're not going to be able to see all of mine. So let's get it a little bit higher. I don't think we still can see it all yet.
No.
Okay, can you see it now? It's a really, really, really long piece.
Yes. Thank you.
So, I don't want this to tip over.
I still can't see it.
So right now, on every table, we have tiles laid out. I want you to think about your tiles going this way. Look at your book. I know this is kind of sideways, but look at your book. You have 1 row of tiles. Do you see the 1? Now you have to tell me how many tiles are in that row. So how many tiles are in your one row? Yes, Adrian.
36.
It is 36. Everybody fills this in. 36. Jacob? Okay. Talking about dimensions, thinking about how to organize our facts. Notice here we're going from one row to two rows. I'm going to say it again. We have some people that are working with tiles yet, working with their partners. We went from one row to two rows. So with our tiles, we now have to arrange them in two rows. So I'm going to pause this while we work on it. Okay, we took some time to arrange ours into rows of two. There is mine arranged into rows of two. Thank you. And how many are in each of the rows? You can count them. David, 18. Okay. I know that the number that comes after, I know that we go 1, 2, 3, 4, 5, but I'm going to just keep going down because we went from 1 to 2. Now it says we have to do 12 in a row. Let's find out what happens when we make rows of 12. How many rows will you get? I'm going to pause while we work on this. Okay, we've been working hard. Most people have something arranged like this, and how many of you all noticed you ended up with 3 rows? How many of you figured it was going to be 3 rows? Okay, people are looking for the patterns. Notice now we're going to 4 rows. I'm going to pause while we do that. Okay, here we go again. Getting back into our dividing these pieces into more pieces. Or should I say our rectangles into more rectangles or bigger, different dimensions. We went ahead and made 4 rows. How many rectangles, how many squares do we have in each of our rows? Somebody please raise your hand. Trevor.
4.
Well, we have 4 rows. How many are in each of those rows?
5.
You should be looking at what's on your table. Kiona.
9.
9. Your answer is right here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now we got to do this last one, number 5. It says we have to have 6 in a row. So I'm going to pause this while we do our work. Okay, we are back. And we all created our 6 in a row. How many are in? How many rows do we have, Safira? She said 6 if you couldn't hear her. What is the shape of our current array? Addison, it's a square. Something you will learn or I will start referring to is this is a square number. Square numbers happen when their arrays are square. Remember yesterday we saw some of those in some of our posters. Okay, this shouldn't take us very long. So here we go. We were told this is 6. So now we have to list the factors. Everybody's going to shout out as we go through this. 1 and
36.
2 and
18.
4 and
9.
blank and 12.
3.
Blank and 6.
6.
Okay, so we're going to answer this question. Number 7, is 36 a prime or a composite number? How do you know? Okay, first of all, let's see. Who's brave enough to decide if it's prime or composite? These are new words. Prime or composite? David's going to take a chance.
1. Composite.
It's composite. He said composite. How do we know that it's composite? I'd like someone else to explain this, unless somebody knows how to explain, unless David wants to explain it, but he might be camera shy. He's camera shy. Luke.
Because it can be split into more than one array.
There is more than one array. Okay? Going according to what Adrian says. There is more than one way to get the product. Okay, now we're going to make this list on the bottom that we've been doing. So some of you that finished up early, you need to join us for number 8. We're going to make our factor table. We put 36 on the top. We're making our factor table. And notice how we do this. 1, 36, 2, and 18. Now remember, I've told you, numbers are predictable. Look for the patterns. Do we have a pattern that's forming? Do we see any patterns right now? Did we double? When we doubled this one got smaller. 3 doesn't fit that so well. 3 and 12. 4 and 9. 6 and 6. So again, what patterns do you observe? We could make this into a few tables, and we could think of 1, 3, and 6 in one of the tables. We could do 1, 2, and 4 in another one of the tables. Notice how those numbers are all related. Okay, this is the end of this part. Everybody want to say bye?
Bye.